Hello viewers, today we'll talk about some of the top 5 architectural patterns. So architectural patterns, top 5 architectural patterns are serverless, microservices architecture, event-driven architecture, service-oriented architecture and containerized architecture. We will not be covering some of the not so much popular such as monolithic or client server these days because we'll cover those in another video. Today we'll focus on these top 5 architectural patterns which is getting used in industry. So let's get started. So first is let's see what is software architecture. So architecture serves as a blueprint for a system. It provides an abstraction to manage the system complexity and establish a communication and coordination mechanism among components. It defines a structured solution to meet all the technical and operational requirements while optimizing the common quality attributes like performance and security. These architecture decision includes selection of structural elements and their interfaces by which the system is composed, behavior as specified in collaboration among those elements, composition of these structural and behavioral elements into larger subsystem, architectural decisions align with the business objectives. Now, what is event-driven architecture? This is the first architecture that we'll look today. So many programs spend most of their time waiting for something to happen. This is especially true for computers that work directly with humans, but it is also common in areas like networks. Sometimes there is a data that needs processing and other items there is not. The event-driven architecture helps to manage this by building a central unit that accepts all the data and then delegates it to the separate modules that handle the particular type. This hands-off is set to generate an event and is delegated to the code assigned to that type. Some of the suitable use cases for this event-driven architecture includes asynchronous system with asynchronous data flow, application where the individual data blocks interact with only a few of the many modules, and third is the user interface interaction with the backend. So in this diagram you can see the event-driven architecture where we have on the left hand side the producers which on different events they produce the events on different use case, and we have the consumer on the right hand side which consume those events. And to manage all the events we have event manager or broker. You must have heard about Camel or ActiveMQ or Kafka. You must have heard about Zookeeper as which acts as a broker for Kafka. This is very popular these days, event-driven architecture. Because we have decoupled applications, one server doesn't know other, so event-driven architecture helps. So you can, in the event-driven architecture, you can have on the one hand the producer, SAP, Salesforce or e-commerce or any other IoT or any other kind of applications which can generate the data and which can be consumed by SAP, ERP, e-commerce or any other system. And to manage those at the transport layer, we have broker, queues, topic, message exchange, etc. This is the typical architecture of a e-commerce platform where we have multiple events such as someone is buying something, someone is just surfing something, or someone is returning returning some item on the e-commerce site. Now for all the tasks that we do, all the actions that we do on e-commerce, some event gets generated such as for new order or a question about a stock, or if you want to return something. All these are managed through the event routes, and they go to the respective database or to the system or to the person or to an server. It may be through the message queue or through API or something will be there which will be consumed by the event consumer. So the producer and the consumer can talk to each other with the help of this architecture. The next architecture which is very popular is SOA architecture, which is also called service oriented architecture. So it is an architectural style that focuses on discrete service instead of monolithic design. By consequence, it is also applied in the field of software design where services are provided to the other components by application components, though a communication protocol over a network. Through a communication protocol, it is provided. A service is a discrete unit of functionality that can be accessed remotely and acted upon and updated independently, such as retrieving a credit card statement online. SOA is also intended to be independent of vendors, products, and technologies. Service orientation is a way of thinking in terms of service and service-based development and the outcomes of the service. SOA is related to the idea of an API, application programming interface, an interface or a communication protocol between different parts of computer program intended to simplify the implementation and maintenance of software. An API can be thought of as the service, and the SOA the architecture that allows the service to operate. So what are the main principles of SOA? So the main principles of SOA are: first is the service architecture, the physical layout or design of individual service that surpass all the resources that were used by a service. Next principle is service composition and architecture. All the services developed using service-oriented design methods are composition-centric, and this is their main feature. The architecture, therefore, is the composition of individual architectures of various services. Third is service inventory architecture. This architecture is formed from the service inventory blueprint, where the service inventory is made up of service that automate the procedure of business. And next is the service-oriented enterprise architecture. This type constitutes of composition, services, as well as inventory architecture. And now this is a typical diagram of service-oriented architecture, where we have used ESB. One of the ESB can be MuleSoft. So we have clients or the consumer group which wanted to consume multiple things such as CRM, order management, or billing. Through ESB they can access it, and they can share the same database or different database as well. So this is CRM, order management, and billing. These are different services which work together with the help of ESB. This is another example where you can see that through ESB the different services such as account service or book service, order service, or shipping service, user is able to communicate with all these services through ESB. They can share the database or can have the independent database as well. Next service next architecture that we'll see is Microservice Architecture. This is very popular for last 5 years. So microservices are small, independent, and loosely coupled. A single small team of developers can write and maintain a service. Here, in microservice, each service is a separate code base which can be managed by a small development team. Services can be deployed independently. A team can update an existing service without rebuilding and redeploying the entire application. Services are responsible for processing their own data or external state. This differs from the traditional model, where a separate data layer handles data persistence. Service communicates with each other by using well-defined APIs. Internal implementation details of each service are hidden from the other service. Supports polyglot programming, for example. Service doesn't need to share the same technology stack, libraries, or frameworks. Now the benefits of microservice architecture is: first is fast time to market. Changes or updates to an individual service can be immediately applied, tested, and implemented. Next benefit is modularity. Services usually focus on a specific objective and are decoupled along the business boundaries. Next is resiliency. Each service is isolated to prevent cascading failure from bringing everything down. Next benefit is organizational alignment. Teams are small and centered around a single component of the overall application. Next benefit is reduction in cost. Microservice lower cost by utilizing infrastructure and development teams more efficiently. Another benefit is flexibility and scalability. Only the components or the feature that require extra performance need to be scaled. Here you can see in this diagram we have multiple microservices such as account, inventory, shipping service. All of these can be accessed through the API gateway, and each microservice can have their own REST API exposed and can access same DB or can have their separate database. This is another example where you can see multiple clients can access the multiple services, where each microservice has different databases. And all APIs are getting access through API gateways. Now next architecture which is very popular is serverless architecture, and all the major cloud providers such as AWS, Lambda, or Microsoft Azure Function, these are very popular. Google also provide Google Function for serverless. So serverless architecture are application design that incorporates third-party backend as a service, and that includes custom code running in managed ephemeral containers or on a function as a service platform. By using these idea and related one like single page applications, such architecture removes much of the need for a traditional always on server components. Serverless architecture may be benefit from significantly reduced operational cost, complexity, and engineering load time, and at a cost of increased resilience on vendor dependencies and comparatively immature supporting services. So serverless is an application delivery model where cloud providers automatically interpret user requests and computing events to dynamically allocate and scale compute resources, allowing you to run application without having to provision, configure, manage, or maintain server infrastructure. Now, serverless gives you a couple of characteristics. First is hostless, elastic, stateless, event-driven, Lego block, high availability, and user-based cost. Why it is serverless? Because serverless allows application to be hostless. Applications are not hosted on a server. It is stateless because interaction and data are not stored. It is elastic in nature because resources are scaled up and down without limits. It is distributed in nature because multiple services are linked for seamless functioning. And it is event driven because resources are allocated only when triggered by an event. So you can see here Microsoft Azure functions. We can have different functions for storage service, content service, identity and access management, and each service can talk to other services, third party or through database or to database. All these can be accessed through API gateways. This is another example where you can see AWS Lambda. Okay, you can implement authorization, content service, or user service through AWS Lambda, and these can be accessed by the web or mobile app through API gateway. And these Lambda service can interact with external APIs or any database. The next important architecture is a containerized architecture. A containerized architecture makes it possible to package software and its dependencies in an isolated unit called as container, which can run consistently in any environments. Containers are truly portable, unlike traditional software deployment in which software could not be moved to another environments without errors and incompatibilities. Containers are similar to virtual machine in a traditional virtualized architecture, but they are more lightweight, they require less server resources, and are much faster to start up. Technically, a container differs from a virtual machine because it shares the operating system kernel with other containers and applications, while a virtual machine runs a full virtual operating system. So what is the benefit of containerized architecture? First is the lower cost on infrastructure operation because you can run many containers on a single virtual machine. Next is the scalability benefit. At the micro service level, eliminates the need to scale VM or instances. Next benefit is instant replication. So with all of this, you can have instant replication of microservices, which enabled through deployment sets and replicas. Next benefit is flexible routing. You can set this up between services. Service supported natively by a containerization platform. Next benefit is resiliency. When a container fails, it is easy to refresh, redeploy with the new container from the same image. Next is full portability between on-premise location and cloud environments. Next is it is OS independent as well, so there is no need to run on a given specific OS. All you need to is to deploy a container engine on top of any host OS. It is fast to deploy and it is lightweight as well. It is fast deployment on new containers. You can also quickly terminate old containers using the same environments, and it is lightweight since containers run without an OS. They are significantly lightweight, much lesser demanding than an image. You can see here in the container based architecture, we have a host operating system, and on top of that we have the container engine, and you can have as many applications as you want or need on top of the container engine. But in case of virtual machines, you have the host operating system, and on that you have hypervisor, and if you need to use multiple applications, you need to have the guest OS, and on top of that you can install your application and binaries. So thank you so much for watching today's video, and if you think the videos are helpful, do like the video and subscribe to the channel.